Okay, in this unit we're going to be looking at complex numbers. Complex numbers are comprised of two parts, a real term and an imaginary term. A and B are both real numbers, and I is the imaginary component. If the A component is equal to 0, then we're just left with BI, and BI is just an imaginary number. If B, however, is equal to 0, then you're just left with A, and A is simply a real number. But you might wonder, what is an imaginary number? Well, an imaginary number is indicated by the letter I, and it is equal to the square root of -1. Now I know for a long period of time you were told, oh, you can't take the square root of a negative number. In the real number system, you cannot. But a complex number is composed of a real and an imaginary number, and so we can use imaginary numbers. I is simply equal to the square root of -1. Now we can look at other types of imaginary numbers. You can put a constant with it, like 4i, and that is simply 4 times the square root of -1. Notice the B part of this problem is the real part, and the I is the imaginary part, which is the square root of -1. By adding a number like 6 plus 4i, we get back to having our complex number, which is composed of two parts, a real part and an imaginary part. Okay, so let's look at some exponents with I. We started off by saying that I was simply equal to the square root of -1. If we multiply the square root of -1 times the square root of -1, we end up with -1. That would be like saying if we multiply the square root of 2 times the square root of 2, we simply get 2. Or the square root of 5 times the square root of 5 yields 5. In the next one, we have the square root of, the I to the third power, I to the third power, which is simply I squared, which is -1, times I to the first, which is the square root of -1. That simply gives us the negative of -1. Or we could call it -I. Then we're going to look at our last one. Our last one is, in this series, is I to the fourth. I to the fourth is I squared times I squared. Now, we found out earlier that I squared was equal to -1. So -1 times -1 is equal to +1. So let's look at some further higher order exponents. So notice that here's originally what we had as our beginnings, and then we moved to I to the fifth, which would be I to the fourth, times I to the first, which is simply 1, erase that a little bit here. I'm losing track. Okay, so it's I to the fourth times I to the first. I to the fourth we know is 1, and I to the first is the square root of negative 1, so that is still equal to the square root of negative 1. I to the sixth is I to the fourth, which is 1, times I to the second, which is negative 1, so we get 1 times negative 1, which is negative 1. I to the seventh is I to the fourth times I to the third, which is 1 times negative I, which is simply negative I. And I to the eighth is I to the fourth times I to the fourth, which is simply 1 times 1, which is 1. Okay. What we need to look at is the fact that, notice I to the 1 is the square root of negative 1, and so is I to the fifth. I to the second is negative 1, and so is I to the sixth. I to the third, I to the seventh, I to the fourth, I to the eighth. Do you see the pattern? In the next slide, we're going to look at a shortcut. In order to do a problem, let's say I to the 17th power, all we have to do is divide 17 by 4 and come up with a remainder, because we all know that I to the fourth, or a power of 4, a multiple of 4, like I to the 16th, times I to the first, well, we all know that I to the 16th is equal to 1, and if we're going to multiply times I to the first, we're going to get the square root of negative 1. So we simply have to divide each of the numbers by 4, and then just determine what the remainder is. So for instance, if I take I to the 403 power, well, we know 4 is going to go into 400 evenly, and then we'd have a remainder of 3. That means that this is still equal to I to the third, which is the negative I. Or if you prefer, you can write it as negative square root of negative 1. And a higher power, such as I to the 102. Well, we know it's going to go evenly. 4 is going to go evenly into 100. So it's going to have a remainder of 2. So it's simply going to be I to the second, which is going to be negative 1. Okay, why don't you try a few of these examples? What do we have to do with I to the 15? Is we just divide 15 by 4, and we're going to get a remainder of 3, because 15 divided by 4 goes 3 times. 3 times 4 is 12, with a remainder of 3. So this is the same as I to the third, which is what? Negative I. 4 goes into 29, you say. It goes in evenly 7 times with a remainder of 1. So this is the same as saying I to the first power, which would be simply I, or the square root of negative 1. I to the 36th power, well, 4 goes into 36 evenly. So that would be the same as I to the 4th, or 1. So if it goes evenly, it's always going to be 1. I to the 82nd power, 4 goes into 80 evenly, and then you're going to have a remainder of 2. So you get I to the 2nd, and I to the 2nd is -1.